So we have a few questions where they're going to ask you to identify your graphs. We've been already doing that, I guess, but we haven't talked about the different types of polar graphs. Identify and graph. But if you have a grapher, it shouldn't be too bad. Verify the polar equation. So r is equal to 13 plus 13 cosine. So what you should notice is they both have 13 in common. So when you factor 13 out, you get 1 plus cosine theta. So this right here is supposed to I guess ring a bell, but we haven't talked about it yet. Let me find the formulas you're gonna need. Where is it? Here it is. So on the notebook notes that I sent you on page 6 or 7, I think, you see these definitions of cardioids. So if it looks like 1 plus cosine, 1 minus sine with the number in front, that number can be 1. It just can't be 0, obviously. But we have a 13, right, in front of our A, for our A. So basically we have a cardioid based on the definition. If A is bigger than 0, the graph of a cardioid passes through the pole. The pole is basically the origin of when you have a polar graph. So when you have a rectangular graph, you have the origin. When you have a polar, we usually call it the pole. Okay. But let's go ahead and graph it. I'll show you how to do it on the machine, on the end, as well as Desmos. But let's do the graphing calculator first. If I can find it. Here it is. So 83, 84, etc. can do polar graphs if you wanted to. I'm not saying you have to, because if you remember the definition or you write the definition on your formula sheets, well, you just say, yeah, cardioid. You can already tell, right? But you can also graph it for fun. So see how when you go to y equals, it's literally says y equals. So you got to switch to polar. So let me clear all this. So go to mode. I believe it's in here. Let me see. Here it is. See where it says function, parametric, polar. Change it to polar. Your menu might look a little different, but it's in there somewhere. Just hit mode and go down the list until you see an option to change to polar. See now how it says R equals instead of Y equals? So now you can graph a polar graph. So 13.
So the POL, right, for polar?
Yes, that's the one.
Okay.
So when you hit X, it's now a theta. You see that? Can you guys see the screen or no? Is that blurry? So when you hit graph, you'll see the cardioid that goes through the pole. Let me see. Let me zoom in better. Zoom. Let's hit trig number 7. See if that works. No, it does not. Standard 6. Zoom out a bit. Zoom out. There we go. So just by looking at the shape, you should be able to tell it's a cardioid, meaning it's like a heart type shape. Let me show you the pictures in the book as well, and on the machine. Where is it? I know that's blurry, so let me open Desmos and hope it does it too.
Mine came up as a straight line. I'm not sure why.
Did you change to polar?
Yeah.
It's probably try to hit zoom standard and try zooming out. It could just have a weird axes or something.
Are you in degrees or radians?
I believe it's in degree. Yeah.
Can you do it again, Professor, on the calculator?
Yeah. Give me 1 second. Okay, yeah, it does work on here. All right, so go to. Did you already change it to polar or you?
Yes, I
okay.
changed it to polar. So
Right.
go hit the Y equals again.
Yeah, so type Y equals and you get to this menu, but now it's
Okay.
all R equals instead.
Yes.
So type in 13 parentheses 1 plus cosine, but when you hit X, it's going to be a theta instead. So you hit, you know, earlier before we would hit like the X button, right? So hit that for the theta.
1 plus cosine and hit the X for the theta.
Yeah.
Okay.
And then you should get a cardioid, and if it's too zoomed, then you need to zoom out or hit
Oh,
zoom.
and then you click graph.
Yeah, hit graph.
Oh yeah, mine's a straight line too.
Hit
Mine's
zoom
a straight line as well.
and press standard. See if that changes.
Zoom and standard. Okay, let me look for zoom. Okay, zoom, and then okay, 6.
Yeah, try that.
Oh yeah, that worked.
Okay, and if you need to zoom out a little more, hit zoom and then zoom out. It should give it to you.
And then
Yeah, that fixed it for me.
Yeah. Okay. Cool.
no.
So it should look like this guy here. I would recommend changing it to see how there's a Cartesian and polar. Each polar makes a little more sense. Okay. If you do it on here, you can also adjust the interval if you need to. Okay. Let me find the notes.
But when we click on zoom out, what are we supposed to do then?
Just press enter. Just choose zoom out and you should be able to see the picture.
Nope.
Yeah, I had to do mine twice and then it worked for me. I did the zoom out twice.
Did you hit
Yeah.
zoom standard first and then zoom out?
Okay, I got it.
Okay. Okay,
Thank
good.
you.
Okay. But I'm not going to make you graph these by hand, so if you use a calculator or Desmos, it's fine. Either way. Let's move on really quick. The one thing I would like you to know is just know what they look like. For example, know that this is a cardioid. It's heart-shaped. Know what a circle is, what a line is, right? That's mainly what I expect. I want you to be able to look at this piece here and realize, okay, that's a cardioid. That's all.
If it has that line underneath there, like that squiggly line, that's what it means.
Yeah, this is the part that tells you that it is a
Okay.
cardioid. Because you see 1 plus cosine. If you look at the book notes here, where is it? Here it is. So I would recommend putting this like on a formula sheet. This is what's telling you cardioid.
Okay.
Okay.
Is the only difference between sine and cosine the way that they face on the graph?
Yeah, pretty much. They'll just be oriented differently. And the A will determine like how big of a curve it'll have at the top of the heart.
Okay.
Like let's go and mess with it for fun. Like let's see what happens, right? If this is a 1, what does it do, right? It scales it. This is a 50, makes it a bigger heart. Now, if it's negative, what happens? It reflects it. We had a regular 13 earlier. So that's just a reflection. If it's a fraction, then what happens? Oops, too small. Gotta zoom in. So it's still same shape, just scaled. So this is scaling it. The minus, see what that does. It's also a type of reflection. Let me put the 13 back. See what happens if I put a sign. Now it's, yeah, flip this way, just like we thought. But as long as one of those, it should be a heart type. Okay.
And why is it a heart shape?
So what's happening is basically you're plotting r and theta. So we're going to, you would choose like an angle. I guess basically it's the same as when you graph y equal x equation. Like let's say you had y equal to x plus 2. You would plug in an x, mark a point, plug in a different x, and then you would connect the dots, right? So the same thing will happen here. So you'd be connecting, put the original back. If I were to force you to do this by hand, you would plug in 0, and then you would mark the point. And then you'd plug in, let's say, pi over 4. You'd plug it in, solve it, and then you'd plug in another point. So because this is a polar graph and it's all based on the angles, it starts going out this way. So you have 1 point, 2 points. So when cosine is, so remember these are angles, right? Make it smaller so we can see it. So when cosine is 0, we get, when the theta is 0, we get 1 plus 1 is just 2. So there it is, 2, right? At angle 0. If you plug in pi over 2, this is 0, so you get 0 plus 1. So at pi over 2, which is right here, we get 1 on this pole here. So we just keep picking angles and we get values. They're not going to be pretty. They're going to be like decimals. So you have 1, 2. So you just keep marking these angles, plugging them into the cosine, and then you add them up, plot the point. So just little by little, it creates this curvature because of the cosine behavior. Does that make sense?
A little bit.
So just do this, and you will see it. So here's r and theta. So pick 0 as your starting point, just because it's easy. Pick pi over 4 pi over 2 pi, let's see, yeah, I guess you could do pi, etc. So you keep plugging these values into here, and then you add it up, and then you find out what r is equal to. So 0 would give me 1 plus 2, that'd be 26. And then you plug in pi over 4, that'd be square root 2 over 2 plus 1 times 13. You get some nasty number. So you just plot it like you used to do on like a regular x and y graph. So it's the same thing. It's just that you're plugging it in angles instead of x values. Okay, let's see. Let's look at the next one.
Professor, before I forget, do we need to send you anything for the student survey once we complete it? Do you need like a screenshot of it, or do you automatically get it?
It'll tell me once like a good, like at least 70% do it. It'll let me know. So at that point, I'll just make sure everybody gets it.
Okay.
But if you don't hit 70, then I'll start messaging you guys. But I should know soon. Okay, so the next one is identify the graph. Same deal. R equals 7 cosine 2 theta. So that double angle is giving you a hint as what kind of graph that is. Let me show you in the notes. So if you go down, where is it? Here we go. You see how it has n theta? So if you have a cosine with double, triple, quadruple angle, it's going to be a rose. So all you have to tell me is what kind of graph that is, rose, and choose a correct graph. The number of petals is determined by the angle, the number times the angle here. So we have 2 theta. So here it says that if n is even and 2 is even, right, then you have 2 times n petals. So we would have 2 times 2 petals for this one. If n is odd, then you just take that number and that's it. So let's go ahead and graph that so you can see it. Okay, so r equal to 7 cosine of 2 theta. Said r. There you go. So see how my n is 2. So it's 2 times 2 to get 4 petals. If I put 3, it's literally just 3. You see? If it's 6, then you expect 12 petals because it's 2 times the even number. But if it's odd, it's exactly that number. Does that make sense? 4 is 8, 2 is 4. But yeah, so just look at the number. If you see a number on the angle, you should just automatically know that's going to be a rose. And that's all I expect from you, is identify what kind.
Well, that's pretty. You did it on the calculator. I like it.
Yeah, it comes out nice, right? You tried it on here too?
I did it on the calculator. Yeah, I don't have my decimals pulled up. So
Yeah, so it'd be the same thing. You just plug in 7 cosine 2 theta. There's my rose. Let me zoom in a bit. Okay. Alrighty, let's move on to vectors. we're not going to do 10.3, so I removed that from your homework. There's only like a couple of questions from on the final about 10.3, so we'll talk about it later when we do the final exam review. So we can make sure you understand the basics. Okay. Okay, so vectors are very similar to, where they're basically based off 2 points. They seem very simple, but they're very important in physics and higher level math stuff, and engineering especially. If you're not going that route, then you probably won't see them again. Yeah, other than physics, I guess. Okay. Yeah. So here we go. The vector. This is the notation for vector. Have a look at a little hat on top. Has an initial point P and a terminal point Q. Find the position vector in the form V equals to AI plus BJ. All right, so that's just the notation they use. Another way they might write it, instead of using the IJ notation, they do it this way. If you see these little triangles, little angled things on the sides, that is implying that it is a vector. Okay, and I'm going to explain what a vector is, but in just a moment. First, it helps to do a simple example.
Is that AI plus B?
BJ. When we do vectors in 2 dimensions, you use I and J components. So I is related to X, J is related to Y, Y direction. If it was 3D, you'd have IJK. So to create a vector from 2 points, all you have to do is subtract them like this. So you have the point 3, 3 and 5, 2. So it's P and Q. So V, we call it the vector V, which is equal to, also the book will use this notation, PQ, because you're making a vector out of those 2 points. So all you have to do is take the final point, which is the second point, subtracted by the first initial point. And then you take the, so that's for like the I component. So 5 minus 3, and then 2 minus 3. It will always be this way. So that gives you the vector 2, -1. Or if you prefer, they will use 2I minus 1J. It's the same thing. So either write it this way or this way. I don't care which one you use. If this makes more sense to you, go for it. It's all good. Now, if you were to graph this, what does this mean, right? It's basically an arrow is the way you graph these. Okay, so 2, -1. So you go 2, -1. So the point is right here. So that's not a point, it is a vector. So you draw an arrow here, and this arrow represents this is a shitty arrow. Fix that. There we go. So this vector or this arrow has what's the word? Magnitude and direction. So mathematically doesn't mean much, but if you apply it to real world stuff, this arrow could represent how much force is being applied at this angle from a real life problem. Or like if you have like a box and you're pushing it on the ground, right? You can apply vectors in different directions. So if I'm pushing it straight on or if I'm pushing it at an angle, you start creating vectors that you will add together to create a total force on an object. So that's what eventually this leads to. But we're not going to do that. That's for physics, right? But the basics that I want you to know is what is a vector? How can you find them? How do you find the magnitude? And how do you find which angle or direction they're going? That's the main thing I want you to learn from 10.4. But without giving a real life example, it's hard to imagine what it means, right? But that's what they mean. It has magnitude and direction, meaning amount of force at some angle. That's in other words. Okay. But it can mean many different things. It could mean velocity, it could mean other stuff. Is there any question on how to find the vector? That's the main idea for number 1. You just subtract first from last. Sorry, last from.
I think it would have been more helpful if the 3s weren't the same, right?
You want me to change the numbers?
Please, just so
Yeah,
that
we could
we
pick
could
any
really
number.
tell which is which.
Sure, just put 1, 2 right here. No big deal. So if you put 1, 2 right there, just change these guys. These 2 3s. It's going to be 5 minus the 1. And then 2 minus 2.
But now we have 2 2.
There we go. Erase this result. You don't like the 2? All right, I'll pick a better number here. How about a 1 3? I think that's better.
I really do appreciate that. Thank you.
That's no big deal. No big deal. All right, so 5 minus 1, 2 minus 3, right? So the result will be 4, comma, -1, right? Which is the same as saying 4i minus j. So 4, -1 would be here. So the arrow would be going this way. But it's always the second minus the first. It's always going to be like that. Okay. Okay, number 2, they start asking you to find magnitude of the vector. So like how big the vector is, basically. How much force, how much acceleration, how much magnetic field, whatever. You know, it's all the same thing. Mathematically, it's all the same. So find the magnitude of V. So another way to say that, let me first write down V. It's -5, comma, 12. So magnitude means double line. This is the symbol for it. Looks like two absolute values. So if you see that on a vector, they're asking you to find the magnitude. And this is the formula to find it. It's actually related to the Pythagorean theorem. That's how you make this. But there we go. Where V is equal to A1, B1, some general vector. So this is how you find it given some vector. So our answer will be the square root of -5 squared plus 12 squared. What's that going to be? 169? Yeah, 13. So the magnitude of this vector here is 13. That's basically the length of the vector. So in the homework, they'll have a few questions where they ask you to find the vector given 2 points. Then they'll ask you to find the magnitude, and then they'll probably ask for both. That's probably the first, I don't know, 4 questions or 5 questions. Any questions on finding the magnitude using this formula? Okay, let's pick another one. 1 second. So the next few questions, they're going to have you add and subtract vectors, scale vectors, and find the magnitude of the results. So nothing crazy. It sounds harder than it is. Basically, you're just going to add them up. So they'll start stuff with, they follow the same rules as basic algebra. Okay, so nothing different. Find the quantity given V is equal to 7i minus 9j, and W is equal to -6i plus 4j. They're going to ask you to find this 6v plus 7w. So you see what they're doing, right?
What's the W? Did you tell us that already?
Yeah, W is defined as this vector here. So I have
And
two
the
different.
W has the little hat, just like the vector.
Yeah, so this is just another vector. This
Okay.
is a V vector and a W vector.
Okay.
Kind of like we have f of x and g of x, you know what I mean? It's just a different name. Doesn't matter. So 6 times v means you're scaling the vector by 6. In other words, just multiply the two numbers by 6. That's all we're doing. I'm using this notation because it's a little easier to see the multiplication and addition. So if you multiply that out, you're going to have 6 times 7i minus 9j. So just treat them like you would x's and y's. Don't let them bother you. Just act like it's the same thing, because it is. So 6 times these two. 6 times 7 is 42, right? 6 times 9 is that 54. Okay. 7 times 6, but it's negative. 7 times 4. That is a weird looking J. What the hell does that say? Seven times 4 would be positive 28. 28J, sorry. There we go. So you guys see what happened, right? Multiply. We scale the first one by 6, scale the second one by 7. And then just add the i's and j's, and we're done. So 42 minus 42, well, that's no more i's, right? They're done. It's gone. Negative 54j plus 28j. What's that going to be? Negative 26, is that right?
Yes.
Okay, so that's it. So this is the new result. So we added two different vectors together, but we first scaled them. So the homework will have you like find what is v plus w or what is v minus w. And that's all you're going to do is just subtract them and combine the i's and the j's. So you can leave it like that, or you can write it in the vector form 0, comma, negative 26 with the little angle things. Both are fine. You technically don't have to write the 0i, but I'm putting it there so you know there is no I component. If you write it this way, you do have to write it, the 0. Is there any questions on the on that problem?
What was that last little part you said at the end? If you write it this way, you don't have to what?
Like this 0i right here, you could just not write that. You could just say negative 26j. Because if I only see this, or if you only see this, it's implied that there is no I component. But if you write it this way, you have to put the 0 here.
With the alligator mouths, or what
Yeah.
are they?
Yeah, whatever those are called. I don't know either. Triangles?
Okay. Yeah, I know them as alligator mouths, but okay.
Yeah, whatever. They look like those less than or greater than symbols, right? But they're facing.
There you go. That
inward.
was the other name I was looking for. Less than, greater than.
Yeah, but they're not.
I'm a substitute, so that's why I'm like alligator mouth.
No, it's okay. Yeah, just remember that, but they aren't. They are not less than or greater than symbols. It's just like a bracket.
Okay, got you.
Don't let them mess with you if you see that in the book.
Right.
They might draw it better in the book than I do. Let's see here. Okay. I couldn't find it. Yeah, they write it like this. Let me show you. Let me zoom in a little bit. See how they have a little triangle thing? They're just prettier. So this means vector, right? Vector. So you can write it like this, AIBJ, or with the little brackets. So mine are like, look more like alligators, but in the book they don't. Okay. I just can't write.
Okay, so they actually represent vector.
Right. But they're
Okay.
vector components. Like
Oh, okay. Thank you.
like when you write the parentheses, it's like a point, right? For X and Y point. This is different. That's why it's not a parentheses. Okay, where were we? All right. So any other questions on number 3? Okay. So so you'll have a few where they add and subtract, multiply, whatever. So all you got to do is this type of thing. But then later they'll ask you to find the magnitude after you add or subtract. So you'll just have one extra step. But the work will be the same though. So let's see here. Find the magnitude. See the little symbol here. V minus W. These are both vectors. If V is equal to negative 3i plus 2j and W is equal to negative 6i plus 5j. Okay, so basically you subtract them first, then you find the magnitude. That's all you got to do. Let me put the light on. It's getting dark in here. Okay. So first step is subtract and find this new vector. Because whenever you add and subtract vectors, you're basically finding a new vector. Okay. So subtract these two here. We're basically, I'm going to put parentheses just so you can see that there's two different ones. Not that you need to. Minus 3i plus 2j minus negative 6i plus 5j. Okay. Actually, give me one moment. Sorry. Sorry about that. Somebody was blowing up my phone for some reason. Okay, so the negative you just distribute just like you would any other time. I'm going to remove these parentheses. I just wanted to show you that this is V and that's W. I'm subtracting them. So distribute the negative. Try to write a nice J here. Negative is 6i. Negative 5j. So we just combine the like terms and you're done. So it'll be negative 3 plus 6. So that is a 3i. 2 minus 5 is a minus 3j. But they didn't ask for that, right? They asked for the magnitude of the difference between the two. So this is the first step. So like you have a few questions that only ask for this, but this time they're asking for the magnitude. So once you find the difference, you find the magnitude. So the magnitude of this new vector that we found is equal to the square root of 3 squared plus negative 3 squared, which will be square root of 18, which is square root of 9 times 2. So that would be 3 root 2. So I can't really see that. So 3 root 2. Okay. So do you see what this is asking when you see this? That's the main idea. Okay. Any questions on numbers 4? All right. So let me do number 5. So I'm gonna do number 5 just so you can see that there's a difference between subtracting and then finding the magnitude, or find the magnitude first and then subtracting. Those are not equal. So let me show you what I mean. So find the magnitude of V minus the magnitude of W. These are both vectors. If V is equal to -4, 5, and W is 2, -3. So that you find the magnitudes first and then find the difference. Over here, we found the difference and then the magnitude. So these are not equal, okay? So the magnitude of V is equal to the square root of -4 squared plus 5 squared, which is equal to 16 plus 25. Right? Which is what? 41? Yeah. Magnitude of W, you take 2 and -3 and square them. That will be 4 plus 9, which is 13.
Can you raise up? Okay.
So the difference is just these two subtracted. Just make sure you, if it's written this way instead of this way, you make sure you do it correctly, okay? We cannot combine this at all, so you would just leave it like this. You can only combine roots like this when it's the exact same root and they have the same number inside. But since the numbers are different, that's all you can do other than changing it to a decimal.
If the number is different, what?
Like if you had, see how it's 41 and 13 on the inside?
Mm-hmm.
They are not the same number, so you cannot combine them.
Okay.
Like if you had 3 root 2 plus 4 root 2, that would be 7 root 2. See what I mean? If they are the same, you can add them. So I have 3 plus 4 of those, so now I have 7 of those. These are apples and oranges.
Okay.
But sometimes they reduce and then they do combine, so make sure you always reduce them if possible. Any questions on 4 or 5? Okay, we're almost done with 10-4. Then we'll take a break. Do a couple more, or a few more examples. So you have towards the end you'll have questions that say find the unit vector. So basically what they do is you have a vector just normal size, and you reduce it to a unit of 1, but it's still going in the same direction. To find the unit vector in the same direction as V. V is equal to 4i minus 7j. Okay. Okay, so this is the formula for a unit vector. So U we'll call the unit vector. So all you do is you take the vector you're given and you divide it by its magnitude. Once you do that, it becomes a new vector, but it's still going in the same direction as the original. It's just that you shrank it down to a length of 1. Okay, that's what this does. Which is pretty handy when you're doing certain types of problems, but we're not going to go too deep into applications. So just use the formula. It shouldn't be too bad. But we have to find the magnitude first, right? So we have V. We need magnitude of V. So the magnitude of V is equal to the square root of a squared plus b squared, which will give us square root of 65. So the unit vector that they want is equal to V over the magnitude of V, which is equal to 4i minus 7j divided by the square root of 65. So you just put the square root on the bottom, you get 4 over root 65 I minus 7j over root 65.
How does I, like, so it's like 4 over square root 65 times I minus,
Yeah, you can put the I on top or on the side. It's the same thing. You can put it over here if you want. You can leave it right next to the 4. So you can see it as a fraction times I, or you can see it as 4i over this. It's the same deal. See what I mean?
they're both right.
Correct.
Okay.
Now we have so to rationalize this because of the square root, so you would have to multiply the top and bottom by root 65, which we've done many times by now, right? Top and bottom by that root cancels the radical on the bottom. They may ask you to do this. Okay. So that's what so it's pretty simple, right? All you do is you take the vector, divide by magnitude. This is the main idea. After that, we're just dealing with that square root on the bottom. And the way you cancel it is you multiply the top and bottom by square root 65. You guys remember from, I think, maybe test 1, we did that. You have any questions on number 6?
So that's the answer on the bottom.
Yeah, so this is the unit vector that's going in the same direction as V, but its length of 1. So we shrank it down to just a one length.
Okay.
Okay, now let's talk about how we can decompose a vector into sine and cosine. Because when we said that these vectors have direction, right? Meaning they have angles. So let's start talking about the angles, and then we'll just 2 more examples, and we'll take a break here. So example 7. Write the vector v in the form ai plus bj given its magnitude. And angle alpha. That it makes. With the positive x-axis. So the magnitude of v is equal to 20. Alpha is equal to 120 degrees. So here they're giving us the magnitude and the angle, and they're asking us to create the vector. So what you need is this formula. So the vector can be written this way. So it's magnitude times cosine of alpha I plus sine alpha j.
Is that on the sentence part, the very last sentence, positive x minus a times b?
Oh, I'm sorry. Yeah, it's x dash axis. X-axis.
Oh, okay, thanks.
All right, so when they give you the magnitude and the direction or the angle, you just plug it in. So the vector will be 20 times cosine of 120 I plus sine of 120 j. One second. Okay. So cosine 120, what's that going to be? That's quadrant 2, which is negative. So this will be negative.
0.5.
Yeah, 0.5 or half, whatever. Sine 120. That should be root 3 over 2, right? So multiply by the 20, and we're pretty much done. We get negative 10i plus 10 root 3j. Or if you prefer, put our alligators right here. There we go, perfect. So these are both right, doesn't matter. But you see how given the magnitude and angle, we were able to actually create the vector, right, using this formula. So we found So given 2 points, we were able to find a vector. Given a vector, we found magnitude. Given magnitude and an angle, we found the vector itself. Just one last thing now. You guys have any questions on number 7 before we do our last example for 10.4?
10 square root of 3?
Mhm.
Okay.
Yeah, 10 root 3.
And how did you get square root 3/2?
Put in the unit circle. It's a sine of 120.
Got you.
Just plug it in there. Then multiply both by 20. Gets you to here. All right, one more and break time. 10.4 gets a little long. Okay. So this time, I haven't talked about finding direction, so let's do that real quick. Find the direction angle alpha of v equal to 4i minus 4j. So to find direction, you can use tangent to help you out, because tangent of alpha is equal to y over x. And using the inverse function, right, we said that alpha is equal to tan inverse of y over x. So using this idea from 10.1, you can kind of treat this as your y and x values. So the alpha would be tangent inverse of negative 4 over 4. That means that alpha is equal to tangent inverse of -1, which will give me -45 degrees on my calculator. But to get the appropriate angle, just add 360. It should be 315, right? If we draw the picture. -45 is over here from the calculator. So just add 360 to get this angle. So the alpha they want would be -45 plus 360. So this is the direction of the vector v. Is there any questions about that?
Yeah, why did you use tangent?
Tangent, you mean as opposed to,
Well, I guess because we don't have the magnitude, right? Oh, never mind.
yeah, so when we always use tangent to find the direction of a vector. So just get in a habit of using this guy. The main reasoning would be because you have a y and x direction. So you just find the ratio, which will give you a unit circle point.
Got it.
But yeah, just think of it as a formula. That's the easy way to think about it. This guy here. Or
So
this guy.
the actual direction angle was the 315, right? Going around the
Yeah.
original angle of
Yeah.
the vector.
Yeah, the vector is going this direction right there. So you technically, both of these are correct, but we try not to use the negative. We prefer the positive. Because I'm still in the same spot, right? And if you were to plot it, you would get what? You would go to the right 4, down 4, so you would be right there. All right, guys, so it's 7:20. Let's see. Let's take a 10-minute break and we'll start 10:05. All right, given vector v, 2i plus 3j, and a vector w equal to 3i minus 2j. Part A says do v dot w. So it's not a times, it's called dot product. Okay. But it behaves like a multiplication. So what you do is you take the i's and multiply those together, and then the j's and multiply those together. You know what? I'm going to pick different numbers because they're the same. Let's pick 5, 6, I guess. Minus 6j. All right, so dot means you take the i's and multiply them together, the 2 and the 5, and then you add the product of the j's, 3 times 6, negative 6. That's all you have to do. So this will give you 10 minus 18, which is negative 8. So that is your dot product.
So on the final product, you get rid of the I and the J and it's just negative 8.
Yeah, it's no longer a vector. It's a quantity. So whenever you do a dot, you no longer have vectors, just a number. Okay, so once you have that, the first few questions will just ask you to dot product a couple of vectors. Okay. For part B, find. Well, you know what? Let's just start a new example, so you could see how this next part works. So given this time, I will use the same numbers so you can see what happens. So I put this on purpose because I want the dot product to zero out. So so v dot w is going to give me 2 times 3 for the i's, right? 2 and 3, plus the j's, 3 times negative 2. So that'll be 6 minus 6, which is 0. So whenever you get a dot product of 0, that means the vectors are orthogonal or perpendicular. Okay. So basically there's a 90-degree angle between them. That's all that means. So if this ever happens when you dot two vectors, it's telling you they are at 90 degrees. Part B, so in the homework they'll also start asking you, find the angle between. Well, I already know the answer, I just told you because of the dot product. But here's the formula. If it wasn't 0, find the angle between sorry, I got distracted. Find the angle between V and W. So here's a formula to find the angle. So the angle between theta is equal to cosine inverse of V dot W divided by the magnitude of V times the magnitude of W. Okay. But notice how we don't need the magnitudes because this is going to be 0 on top. Excuse me. So it'd be cosine inverse of 0 over the magnitudes, right? But you see how this is still 0. So who cares? Let's not do extra work. So this gives me 90 degrees, which we already knew. We knew that these two vectors are orthogonal. Okay. Let's do example 2. Guys have any questions on example 1? So yeah, this is the dot product, and this is the formula for angles between two vectors. It's the only thing, the only new stuff we've done. So given a vector v equal to square root 3i minus j, w is equal to negative I minus j. All right. So this time let's do all the work where we have to find the magnitude and the dot product and then the angle between. So v dot w, you simply multiply the i's together. So root 3 times negative 1 plus negative 1 times negative 1, right? Ouch. So that will give us negative root 3 plus 1. So there is my dot product. It's no longer a vector, it's just some number. Okay. Any questions on the dot product? Do you see where the numbers came from? See how there's no number here, but it's negative, so that's why I put negative 1 here. Okay, part B. Find the angle between. All right, so the formula we said is this. The dot product over the magnitude We already have the dot product, so that's great. So we're gonna have to find. Oh shoot, forgot to write. Dang it, cosine inverse in front. Oh well, write it again. Cosine inverse of v dot w over the magnitude of v times the magnitude of w. All right, so we're going to have to find these two magnitudes before we do anything. So the magnitude of v is equal to the square root of, where's v? Right there. So square root 3 squared plus -1 squared. That will give us the square root of 4, which is 2. Okay. Magnitude of w would be the square root of -1 squared plus -1 squared. So that'll be square root of 2. So now plug it into your formula. So theta is equal to cosine inverse of v dot w over the magnitude of v times the magnitude of w, which is equal to cosine inverse of the magnitude of the dot product already did up here, so I'm just going to plug that in. So up here, put minus root 3 plus 1. On the bottom, we have the magnitude of v, so that's 2 times magnitude of w, which is root 2. So all this goes into your calculator, giving you an angle of about 105. Any questions on this problem?
Do you mind doing it on the calculator, that last part?
So you have cosine inverse. So without the fraction, you'd put negative square root. Where's my square root button? 3 plus 1. So that's the top part divided by the bottom part. 2 times square root 2. Yeah. So 105.
Thank you.
Okay. So one last example and we'll call it a night.
So I'm getting something a little different. I'm getting 15. Why am I getting 15 on my calculator?
You in degrees?
Uh-huh.
Did you put the parentheses correctly?
Yeah. Oh wait, let me see.
Double check.
Yeah, I got that too, but then I redid it and I got 105. So
Yeah, be careful with the parentheses and how you punch it in.
Okay, I'll keep messing with it and see what I get.
I recommend like the top of the fraction, put parentheses divided by parentheses, bottom part of the fraction. That way you can't mess it up. All right, so number 3, the last thing they'll ask you in this section is to decompose one vector into 2 separate vectors. using a formula. So as long as you follow the formula, it's not too bad. So decompose V into vectors V1 and V2, where V1 is parallel to W and V2 is orthogonal to W. So here's the V. Here's the W. All right, so this is the formula you need for V1 and V2. So V1 will always be found this way. So you do a dot product on the top with the original V and W, and then you divide that by its magnitude squared. And then you dot it by W again. This gives you V1. V2 will simply be the original V minus the result you got from V1. So V2 is easy once you get V1. Okay, so use these two formulas to do the decomposition the way they asked it. All right, so let's do the dot product first, and then find the magnitude of W squared. Let's see how that goes. V dot W is equal to 12 times -1 plus 4 times 1. So that'll be -12 plus 4, which is -8. So there's my dot product for V and W. Now, magnitude of W squared is the square root of -1 squared plus 1 squared. So you're squaring the magnitude, right? Which is going to cancel the square root. So you're going to get square root of 2 squared, which is 2. So there's my magnitude squared. So that part's going to go down here. I got the top part, -8. So I can start trying to find V1. So V1 is equal to the dot product, that we already found this, divided by the magnitude squared, which we just found, dotted with W again. So that would be -8 over 2 times the vector W, -1, so -I plus J. So that would be -4 times -I plus J, which is 4I minus 4J. So this is V1 right here. But that's the hard part. Once you have that, V2 is super easy. So V2, we just use the formula, is V1, V minus V1. And that's it. So here is V, the original, 12I plus 4J minus the result I got from V1, 4I minus 4J. So that will be 12I plus 4J minus 4I plus 4J. So 12 minus 4 4 plus 4. So that's it. There's V1 that they asked for, which was 4i minus 4j, and V2, which is 8i plus 8j. So just use these two formulas, and that's all you have to do. So whenever you see decompose V into two vectors, this is the formula you got to use. Is there any questions on these examples? All right, we'll stop here, and next time I'll leave some time for homework problems if you get stuck.
Okay.
All right, guys, have a good night, and I'll see you on Tuesday.
Awesome. If you could just leave it up for just a little bit longer. I'm a little behind. My internet lagged for a minute there.
Oh, it's okay. So there's no rush. No, I'm not closing it yet.
Thank you, Professor. Have a good night.
You too. See you later.